Drawing heads is mostly a construction problem. If you understand the simple 3D shapes that make up the head, you can draw faces in any style and from any angle. Because you're not copying a symbol anymore, you're building a form. So the real question is, how do you train that understanding? If you've seen my previous head video, literally my first video on this channel, I mentioned some practice methods, and this video is basically an upgrade to this. We're going to use the Loomis method as our main construction, but before we jump into it, there are a few key things that you need to understand. Let's start with tilting the head. First, we will draw a circle, then draw a line that wraps around the head horizontally like a belt. This is your main wrap line. Now add a second line down the middle, but this one is tangent to the circle. In other words, it's not going to wrap. Don't curve it. This tangent line is the important one, because its tilt and position determines the angle of the face. Now there's a rule of thumb. Those two lines should always feel like they're forming a believable cross on a 3D ball. If the cross doesn't make sense in 3D, the head won't either. Now let's look at the head in a front view, no tilt. First, we slice off the sides of the circle. How much you cut can be confusing, so honestly, find your sweet spot through practice. The more you cut, the flatter the sides, the less you cut, the rounder the head. And it also affects how narrow or wide the jaw will feel. Now, we will divide the face into the sections using horizontal guidelines. Now, this is very important. These lines must follow the angle of your wrap line. So if the head tilts like this, all your section lines tilt the same way. Now this keeps the construction stable and prevents errors later. Now I also like adding one extra guideline right under the circle, the jaw break, because it shows where the jaw changes direction. This works perfectly when there is no tilt, but when the head tilts, something happens. In some angles, only one side of the jaw will touch the jaw break line, while the other one shifts and lines up closer to the chin level instead, or sometimes just a little bit above it. Here's another example. So now the question is, how do we find the other jaw corner without guessing? And for that, I would like to show you my extra construction method to locate this hidden jaw. So this method adds a few more lines to the construction, but it makes the jaw placement way more reliable. First, get your main Loomis method set up. The side plane circle, the face sections, wrap line, and the center line. On that wrap line, the belt, try to draw it fully so it actually wraps around the sphere. Now we're going to build a half box around the side plane circle using two tangent lines. One tangent that is horizontal to that side plane circle and another one that is vertical to that side plane circle. Not perfectly horizontal or vertical, because the tilt changes that, but I hope you understand what I'm meaning with this. The key is, each line should barely touch the outermost point of the circle on that side. Now these two tangents form a cross. From that cross, we're going to draw a diagonal that goes between these two lines. This gives you the slant direction that we need. Use the diagonal direction to project across the head from the center of the visible side plane cross, and you draw a diagonal line until it hits the other arc of the wrap line, the part of the wrap line that goes behind the sphere. Now that hit point tells you where the other side plane cross section would be, in other words, the other joint of the jaw. Then you draw the corresponding vertical line through that point, matching the tilt until it reaches the jaw break line. And that way you found the first jaw placement. Then to find the second one, we will extend this vertical line of the cross section of the original one, and using the same slant of the diagonal that we used before, we will connect the jaw break section that we just found and extend it until both lines intersect. And there you will find the second jaw break location. If you connect both jaw corners, you get the underside plane that often sits in shadow. Now, why does this work? Both jaw corners sit on the same level line on the skull. When you tilt the head, that connection still exists. You just can't see it clearly. The what I like to call tangent box method helps you find that invisible connection by using the sphere's outermost points as reliable anchors. Also, on the side plane, you'll notice there's a vertical cross section too that helps place the ear, and it also lets you build the cheek plane cleanly. From this base, we add features as forms, not details. For the nose, we can start with a simple wedge shape or just a plain circle like I like to do. For the eye area, we build a simple visor, which is the eye socket plane, and for the eye sockets themselves, I just draw a little box on the general location where they will be. For the ears, think ovals. placed using these side plane guidelines that we had just created. Now, there's a core idea behind this. You're not drawing eyes and the nose, you're just constructing the planes where these will be sitting on. So even when you draw over them, they don't look exactly the same. That is fine. This is merely a guideline for you. So now that you have a stable construction, how do you get good at rotation? My biggest recommendation is that before you draw faces, use this construction that I just showed you to draw skulls. It sounds harder, but it's actually easier for learning rotation because skulls remove the distraction of pretty features. You mainly focus on the eye sockets, the nose sockets, and the mouth area, also known as the jaw. And that should be enough to train real 3D understanding. When the head tilts up or down, the face sections shift. Usually 2 of the 3 sections stay similar and 1 section stretches. For instance, in this very low angle, the hairline to eyebrows and eyebrows to nose sections are about the same in size, whilst the nose to jaw section is stretched. On a high angle, or when the head is tilted down, it's a little bit different. The hairline to eyebrows and eyebrows to nose sections are about the same in size, but the jaw area is actually a bit smaller. Depends on how extreme the angle is though, so remember that. Also, most of the time, the eye and nose areas compress depending on the angle. In the low angle, for instance, they basically overlap with each other, and on a high angle, they are squished, but they're not overlapping. Now, regarding the eye sockets, here's the key. Your guidelines control the eye shape. When the head tilts, either the top of the eyelid or the bottom starts to follow the construction more strongly. From above, the upper eyelid tends to follow the guideline more, and from below, the lower eyelid tends to follow the guideline instead of the upper one. That's why eyes looks wrong in angles sometimes, because people draw the same eye symbol every time instead of letting the guidelines steer the eyelids. Now, regarding the jaw, which is what I think everybody struggles with, once you know the locations of each jaw break from the previous construction that I showed you, what you want to do is to leave the drawing of the jaw suggested. For instance, in this drawing, though I could clearly draw the full jaw in this tilt, it actually looks better if you leave merely the line marks that suggest that it is there. And if you wish to actually show it, it is better to show it with shadows. Another way to estimate how big the jaw will be on extreme tilts is first, what you want to do is to estimate the length of each sections of the face, mainly the hairline to eyebrows and the eyebrows to nose sections. When you have this done, then for the mouth section, it will be around 1.5 times the length of these areas if seen from below, and about half the normal length of these areas if seen from above. And if you use the construction that I show you, you shouldn't struggle positioning the jaw itself. Now, the ears, if you follow the side plane, you'll place them in the right zone, even though from below they sit lower than people expect. So for the neck, let's keep it simple. You really just mainly need to draw that muscle that runs from behind the ear down to the collarbone, so you can get away with 2 tubes diagonally from behind the ear and then a cylinder that connects the neck. Now, when you look at the face from above, it is the same logic, but it's flipped. This new construction that I showed you won't be particularly as useful, because for this angle you really just need the normal Loomis method construction that I showed you in my previous video. Now, the nose in this angle tends to protrude a little bit more, and people assume you won't see the mouth or the jaw, but that's only at extreme angles. Most of the time, you will actually see them. As stated before, the length of the jaw will be smaller this time, and the other 2 sections will be about the same size, whilst having the visor and nose area a tad bit squished. For the mouth, you just gotta keep one thing consistently. You gotta make sure that the upper lip line follows the curved direction of your original rep line. Basically the same direction as the brow line, and then from that, you can stylize the rest however you want. Now, when the head turns sideways, part of the face won't be visible, but when you're practicing with skulls, still construct a hidden side anyway. Training yourself to build what you don't see is one of the fastest ways to improve your 3D understanding. Construction-wise, this is the most consistent way that I know to learn heads from any angle. And once you understand this, you can tweak it to match the different styles that you want. Now, I'll leave you with a time-lapse of me drawing faces, and you can click away if you want, but watching other artists draw helps you build your visual library, and you can draw along and compare. With that said, keep drawing, don't stop practicing, and I'll see you in the next one.